Hi, we are going to be looking at prime numbers versus composite numbers. The word composite is similar to the word compose, and compose means to make or make up. So a composite number is a number that has three or more factors, and a prime number is a number that has only two factors, one in itself. When I talk about factors, remember, I'm talking about a multiplication problem. So I have two factors that work together to make a product. In the case of a prime number like 3, the only whole numbers that I can use to make 3 are 1 times 3. There's no whole number that I can multiply by 2 to make 3. And I can't use a number that's larger than 3 because my product will be larger than 3. So in this case, 3 has only two factors, 1 and 3 itself. If I take another prime number, which is 5, the only way that I can make 5 is by multiplying 1 times 5, 1 times itself. A composite number, on the other hand, can be made multiple ways. So let's take a look at the number 8. I can make 8 by multiplying 1 times 8. I can also make 8 by multiplying 2 times 4. All of these numbers are factors of 8. So you can see here, 8 is a composite number because it has 1, 2, 3, 4 factors. It's not limited to only 1 and itself, 1 times 8. Let's take a look at another composite number. 12 is a great composite number because there are a lot of different ways that I can make 12. I can make 12 by multiplying 1 times 12. I can multiply 2 times 6, or I can multiply 3 times 4. If I look here, I have 1, 2, 3, 4, 5, 6 different factors that can be used to make 12 when I multiply them together. So 12 is a composite number because it can be broken down more than one way. I have 3 different ways to make 12 using multiplication. I have 2 different ways to make 8 using multiplication, but I only have one way to make 3 or 5 using multiplication of whole numbers. When I look at this hundreds chart, I'm going to highlight the prime numbers. 1 is technically a prime number because it can only be divided by 1 and itself, which is 1. But it's also unique because in both cases I'm thinking about 1, but I'm going to color it in here. 2 is the only even prime number that I have. And that's because every other even number can be divided by 1, but it can also be divided by 2. So 2 is the only even prime number that I have. 3 is a prime number. 5 is a prime number. 7 is a prime number. Now, even though 9 is an odd number, it's a composite number because it can be divided by 1, by 9, or by 3. So I have 3 or more factors. Every other even number, so 4, 6, 8, 10, 12, 14, those are all going to be composite. They can all be divided by 1 and themselves. They can be divided by 2 and by another factor. 11 is a prime number. 13. 15 is not prime because I can divide it by 1, 15, but I can also divide it by 3 or 5. 17 is a prime number, and 19 is a prime number. When we're thinking about prime factorization and prime numbers, these are going to be some of the most important ones. There are a lot of other prime numbers. For example, 37. However, these ones in the first 20 numbers of my um, number chart are going to be the ones I'm going to use most often for prime factorization because I don't have other ways of breaking down my numbers. And these are going to be sort of the base building blocks to make a whole bunch of larger numbers through multiplication. So I want you to take a moment. I want you to study these numbers and really focus the um, on the numbers in the first two rows of your number chart. Those are going to really help you. And if you still don't understand what prime and composite numbers are, I want you to let me know and we'll take a look together.